this is part B of the video for 8.2. So this is going to be a short video, and the whole thing is kind of your practice problems. There won't be a separate set of practice problems. So I want you to treat each one of these problems that we do as a practice problem. And pause the video if you need to, and just try doing it. And you can do it any of the ways. I'll probably give you a heads up as to which way might work the best. But okay, so the first way that we learned was by factoring. So you factor it and you use the zero product rule. And we did this back in 5.8, right? So this is a great way. It's probably the fastest and easiest if you can factor the equation easily. So here's an example. You have this equation that you can see easily factors into 3 and 5 are the two numbers that multiply to be 15 and add up to be 8. The second one was the square root property. And although it says complete the square if necessary, we actually didn't learn completing the square method, so you wouldn't be doing that. It's really good if you have something in this form where you can quickly just subtract the c over divide by a and then take the square root. And if it's in this form, you can do the same thing. You can take the square root, a plus or minus, right? And then add the a over. This is the one we're not going to do because that would be completing the square. All right, so here's a couple of examples. The first one is the one we want to look at. We're not going to look at that one. We would subtract the 9, divide by 4, and then take the square root, right? And so it would be plus or minus the square root of negative 9/4, which would be 3/2 I. So plus or minus 3/2 I. The other is the quadratic formula, where you're going to just, if it's in this form, then you would plug it into the quadratic formula, which is, I don't know why it's not on here, negative b plus or minus square root of b squared minus 4ac over 2a. So hopefully you'll have that down. Write on your note card though, so that you can, if during the test you freeze up and can't remember, it'll be right there for you. Okay, so here's the first one. I want you to solve it using any method. Of course, first you have to get it into the standard form. So you'll have to multiply this out, add like terms, get everything on one side, right? So pause the video, see if you can do it. Okay, so hopefully you're able to do it. There it is, all multiplied out. This was our x squared plus 6x plus 9. Don't forget the 6x. I hope you didn't forget that. And then we'll add like terms. So here we have this 2x squared minus 3x plus 1. Notice that if we took 2 times 1, that's going to be a positive 2. And if we did a negative 2 and negative 1, I'll be darned. It's going to factor, right? It'll factor, and it factored pretty easily. Comes out to be 2x plus 1 and x minus 1. So these are our two numbers. If you put it in the box, you would be doing 2x squared minus 2x minus 1x plus 1. That'd be how you'd factor it in the box. All right, so our two answers are positive 1/2, because this is equal to 0, or positive 1. All right, here's the next one. Solve this equation using any method. Make sure you get it into the standard form first before you decide whether you can factor or not, or whatever. Okay, hopefully you figured this out. We put it in the standard form. So I think we're going to do this. Well, first of all, if you look, 5 is only 1 times 5, and they're both the same sign, so it's no way going to add up to 2. So we're kind of left with, we would have to either do the square root property with completing the square, which we didn't learn, or the, which is the way that we did it here. The way the PowerPoint did it was that way. So I'll do it for you with the quadratic formula, right? So A is 1, B is 2, and C is 5. So x is equal to negative b plus or minus square root of b. B squared is 4 minus 4 times a times c, or 2 times a, which is just 2. Okay, so up here I have 20 with the 4 and the 5, so 4 minus 20, which is negative 16. All right, so negative into the radical means there's an I, and the square root of 16 is 4. So this is negative 2 plus or minus 4i over 2. So we'll just split that into 2 parts, right? So negative 2 over 2 plus or minus 4 over 2i, which is negative 1 plus or minus 2i. All right, well, that's what they got. We caught up with them. So the two solutions are negative 1 plus 2i and negative 1 minus 2i. Okay, solve this using any method. I would suggest you get rid of those denominators, so multiply everything through by 9. So pause the video, see what you can do. Okay, hopefully you're able to figure it out. Multiply through by 9, and that's going to clear all those denominators. And the first one will be, when you have 9 over 3, that's a 3. So 3x squared negative 5x plus 1. So 3 times 1 is 3, and if I would only have 1 and 3, but that's going to add up to 4, not 5. So I can't factor. So this is going to have to be done with the quadratic. So there are 3 numbers. Plug them in to the negative b squared. So that's negative 5, right? So that makes positive 5. And then negative 5 squared minus 4 AC. 4 times 3 times 1. And over 2a, we simplify that all down to 5 plus or minus 13 over 6. Those are our two answers. Okay, here we are with the next one. So if you notice, this is in a different format than the others. We don't need to factor. We don't need to do the quadratic. We could just solve it with the square root property. So pause the video and see if you can do it. All right, let's see what we get. First, we add the 11 to the other side, because when we're doing the square root property, we don't need to have it equal to 0. And then we'll divide by 9, and then we take the square root. So it's plus or minus the square root of 11 over 9, and you know that we don't leave denominators under the radicals, so we would rationalize we just have to take the square root of 9, and that will be our 3. So those are our two answers. All right, that's it. Hopefully you kind of got used to the 3 different ways we did it of factoring, and if you have questions on any of them, bring them to class and we'll talk about it there.